Hi everyone. Hi everyone. Good evening, good morning, depending on the time zones you are in. Hi, my name is Ajit Pal Singh. I welcome you all in my LinkedIn live session on cryptography. This is session 3. I already have covered 2 sessions earlier in which I have covered basics of cryptography. Along with that, in a second session, I've covered symmetric, asymmetric cryptography along with TLS and hybrid cryptography. So this is the third session in the series in which I will cover another important goal of cryptography, that is integrity. In this session, I will take you through uh, hashing, digital signatures, and PKI. So this is the last and final session. After that, in the next session, I will take you through uh, quantum computing, quantum cryptography. So let's start now. Hope everyone is able to hear me loud and clear. If yes, then please let me know on the chat. Okay, so let's start now. So this is the third session, as I already mentioned. In this session, we will cover hashing, digital signatures, and public key infrastructure. It's not public key cryptography, it's public key infrastructure. There is a difference between the two. Public key cryptography is another name of asymmetric cryptography, and public key infrastructure is something different. So let's start now. So first one is hashing. In our previous sessions, I have already covered symmetric and asymmetric, in which we have seen that how you can, in which we have seen that with the help of symmetric and asymmetric cryptography, you can achieve 3 goals of cryptography. That is confidentiality, authentication, and non-repudiation. So one goal of cryptography was missing, that is integrity. In total, there are 4 goals of cryptography: confidentiality, which is being provided by symmetric cryptography; authentication and non-repudiation, which is being provided by asymmetric cryptography and digital signature; and integrity, which was missing. So in this session, hashing, in this session, we will see how you can achieve integrity. So hashing is an algorithm which can help you in achieving integrity. Integrity means what? Integrity ensures that no one has tampered your data in an unauthorized manner. So integrity can be achieved with the help of hashing. What is hashing? Why we call it one-way hash? Because hashing is irreversible compared to encryption, which is reversible. In encryption, whatever you convert it into plain text, whatever you convert into ciphertext with the help of algorithm and the key, you convert that into ciphertext. You convert that into a plain text by the decryption process, so that intended people can read it or intended process can process it. But in hashing, it doesn't happen like that. You don't try to reverse the process. That is why hashing is irreversible and we call it as one-way hash. What is hashing? Hashing is an algorithm which takes variable length data as an input and give you fixed length digits as an output. So it is used for integrity. So let me show you how hashing works basically. So as I already mentioned, hashing is an algorithm which takes variable length data as an input. When I talk about variable length could be a single character. It could be a word, CISSP. It could be a sentence, I pass CISSP. It could be an email, and it could be 600-page book. But in all the cases, you will see when you input this into an hashing algorithm, it will create a text, a fixed length text. So you see in all the cases, the length is same, but text is different. So hashing is an algorithm which takes variable length data as an input and gives you fixed length digest as an output. Digest is random nuance of number, and that varies depending this length of the digest. It depends upon algorithm you are using. If you are using MD5, length is 128 bits. If you are using SHA-1, length is 160 bits. If you are using SHA-2, SHA-2 comes into different variants: 224, 256, 384, and 512. So this depends upon this 224, 256, 384, 512. This depends on the length of digest it creates. So as of now, MD5 and SHA-1, we are not using it. It's obsolete. We are using SHA-2, SHA-224, 256, 384, 512, up to you, whichever you want to use. So how hash works basically. So let me show you how hash works. As I already mentioned, hashing is an algorithm which takes variable length data as an input and gives you fixed length digest as an output. And it is mainly used for providing integrity. So let's take an example. There are A and B. A wants to send an email to B. This is an email. A wants to send an email to B and wants that email should not be tampered in transit. So email will be fed into hashing algorithm at the receiver side, sender side. This hashing algorithm will generate a digest. Suppose let's take an example, it is ABC. This digest will be appended to email and send it to B. What B got, email and message digest. B will separate these two, email and email will be fed. The email B has received from A will be feed into hashing algorithm again. It should be same algorithm. If you have used SHA-1 here, so it was SHA-224 here, so it should also be SHA-224. Again, a digest will be created. The digest which has been created by B by using email as an input, and the digest which B got it from A, that will be compared. If they are same, which means that data has not been tampered. So this is how you can ensure integrity. Another example, suppose there is a log file. You have generated log file and you have stored it for a later use. So once a log file is created, you create a hash digest of it. Then you will safely stores hash value in some place. Now suppose a month after you need, suppose a month after you need to use that log file, and you need to check whether the log file has not been tampered or not. So in that case, you will again create a hash digest from the log file. And now you will compare this hash with the hash that you have created for the first time when log file was created. If those hashes are same, which means that it has not been tampered. So this is another example where you can use hashing. So hashing, it's basically a hash function uses an algorithm without any key for encryption. This encryption cannot be reversed. Hence, it is called as a one-way. A fixed length hash value is created or hashed from a variable length digest. This is what I said in the beginning, that it is an algorithm which takes variable length data as an input and gives you fixed length digest as an output. Hash will help you in providing integrity. because if the hash value changes, then you will come to know that data has been tampered. Hash can be applied to data block of any size. But remember, output, the length of the output will always remain fixed. Output will be different, but length of the output will remain same depending on the algorithm you are using. It produces fixed length output. It is in the image also, it is very clear. It takes variable length data as an input and gives you fixed length digits as an output. So characteristics. It is computed over the entire message. To ensure the integrity and correctness of a hash value, you should always process it over the entire message. It's not like that there is a 600 page book, you calculate the hash of 300 page book and remaining no complete. It's a one-way function. You have seen in the diagram also, at the other end, at the receiver side, you don't try to reverse it. You try to calculate the hash again and compare it. If a given message and a hash value, it make another message with the same hash value impossible. It is resistance to birthday attack. What is birthday attack? There is a term called hash collision. What is hash collision? If there are, if two different plain text, if two different plain text are encrypted upon by, are hashed upon by the same hash digest, then if it result in a same, if two different plain text hashed upon by the same hash digest, same hash algorithm, if they result in a same hash digest, then we call it as a hash collision. Suppose, for example, ABC, ABCD. I input into hash algorithm MD5, MD5. If they result in same hash digest, then this is called as hash collision. This condition is not at all desirable. This condition is not at all desirable, and larger the length of digest, the lesser it is susceptible to this birthday attack. So there are different hash algorithms available. MD5, I've already mentioned, it is most widely used, but earlier days. It creates a 128-bit hash value. These days, it has been obsolete. At present, SHA-2 is going on, which comes into four variants: SHA-224, 256, 384, and SHA-512. The larger the length of digest, the more, the better it is, the more secure it is, and it is less susceptible to birthday attacks and hash collision. So let's look at, I've already shown you through a rough, with the help of rough diagram. Let me show it in a more formal manner how hashing works. Suppose there are two people here, Charles and Alice. Charles want to send an email to Alice and ensure that it is not tampered with during transit. So hashing communication process at the sender side. Charles input an email into an hashing algorithm, and you see a digest is created. A3421, a digest. A fixed line digest is created as an output. This fixed line digest is appended to the email and send it to the receiver, who is Alice in this case. So this is the communication process at a sender's end. Now, at the other side, when Alice receives an email, what she does? She will remove the digest and input an email again into an hashing algorithm. Again, a digest will be created. Now, the digest which Alice has received from Charles and what she has calculated right now, computed it right now, both will be compared. If they're same, data has not been tampered. Then, what are the practical use of hashing? I've already mentioned the practical use of hashing with you. That is it is used for checking whether the data has not been tampered. One of the very common use is password verifications. The passwords are not stored in a clear text format in your in password database. Passwords are stored in the form of hashes so that even if someone gets access to your password file, he won't be able to get, he won't be able to know your passwords. Then signature verification. It is also used in digital signatures to confirm the authenticity of documents or messages. It is used for data integrity checks. Let's take one example. Suppose you have downloaded a patch from the Cisco website. Sometimes what happens, the patch gets corrupted while you were downloading. So Cisco or all vendors, they do have a hash value mentioned at their websites along with the patch. Now, when you download it, you will again calculate the hash or a checksum value and then compare it with the one which is mentioned in the website. If they are same, the patch has not been corrupted. So hashing is primarily used for integrity. Then what is birthday attack? As I've already mentioned earlier, birthday attack is related to hash collision. What is hash collision? If two different plain text which are hashed upon by the same hash algorithm, if they result in a same hash digest, then this is called hash collision. Birthday attack is based on the probability. If there are 23 people in a room, then there's more than 50% probability that they have the same birthday. Now, if you correlate, now if we talk it in terms of hashing term, if there are 23 people in a room, then there is more than 50% probability that 23 that 50 there is more than 50% probability that two people password will be hash collided, which means that two people password hash digits will be same. Remember one very important point: the larger the length of digest hash algorithm creates, the lesser it is vulnerable to birthday attack. If you are Suppose there are four algorithms you are using: SHA-1, SHA-224, SHA-384, and SHA-512. So SHA-1 should be most vulnerable, and SHA-512 will be least vulnerable and susceptible to birthday attack. To avoid to prevent it from birthday attack, you should use you should use uh, the the latest SHA algorithm, latest hashing algorithm with a larger with a larger message digest. Along with that, you can take another measure which we call as a salting. Salts are the random numbers which is added to the hashing process to make it more random and to prevent it from hash collision. So even if there is a probability that it may result in a hash collision, but when you add hash salts to it, this will prevent that thing. So this is about your hashing. Now there is another very important concept which we call as digital signature. Digital signature is basically a process, a technology which help you in achieving three cryptographic goals: authentication, non-repetition, and integrity. It uses two technology: hashing and asymmetric cryptography. Hashing helps you in providing integrity, and asymmetric cryptography, it helps you in providing authentication and non-repetition. If you listen to my previous session, in that I have already covered asymmetric cryptography. In asymmetric cryptography, there are two types of communication: secure message format. Whenever you are looking for confidentiality, you will go for secure message format. In a secure message format, you always encrypt the data using the public key of a receiver and decrypt it using private key of a receiver. And whenever you're looking for authentication and non-repetition, you will go for open message format. In that, you will encrypt the data using private key of a sender and decrypt it using public key of a sender. So here we are looking for authentication, non-repetition, and integrity. So we will use open message format communication of your asymmetric cryptography along with hashing. So let me take you through that how that works, and then I will take it formally with the help of slides. Suppose there are two people, A and B. A is a sender and B is a receiver. A wants to send an email to B. A wants to send an email to B in such a way that email is not tampered in transit, one thing, and B is able to authenticate A sender, and A cannot deny sending the message. That is another thing. So let's see how this works. So let's see, this is an email. Email is feed into hashing algorithm. A message digest is created. Suppose this is ABC. This message digest is for integrity. This message digest is for integrity. So integrity will be achieved through hashing. Now we are looking for authentication and non-repetition. Remember, whenever you are looking for authentication and non-repetition, always encrypt the data using private key of sender and decrypt it using public key of sender. So authentication non-repetition will be achieved through asymmetric cryptography. So for participating in asymmetric cryptography, you need to generate private key and public key. And here also you will generate private key and public key. And you will exchange each other's public key. So PBA, PBB. So A will have public key of B, sorry. A will have public key of B and B will have public key of A. So this is done. First step of asymmetric cryptography is done because you generate private key and public key and you exchanges each other's public key. So for hashing, we have created a digest. For integrity, we have created a digest. Now we are looking for authentication and non-repetition. So for authentication and non-repetition, you will encrypt this message digest with private key of A. As you are looking for authentication and non-repetition, in authentication and non-repetition, you have to encrypt the data using private key of a sender. So who is sender here? A. Remember, you don't encrypt your email. Email is just used for calculating a digest because confidentiality is not an original goal of your digital signature. So you have encrypted this message digest with your private key of a sender, that is A. So now this is your encrypted ABC. This is called as digital signature. This is called as digital signature. Now you will append this digital signature with email. Email is being sent in a clear text format. Now you will append this with email and send it here. So email and email, basically you will separate it, these two. So this, you will separate email and a message digest that you have received. First thing, when we received an email and a message digest, it will focus its attention on message digest, digital signature, which is encrypted. So it has been encrypted using what? It has been encrypted using private key of a sender, that is A. So B already have a copy of public key of A. So B will use that public key of A to decrypt this digital signature. If he's able to do that, this ensures authentication and non-repudiation. Because if B is able to decrypt it using public key of A, which means that it has been signed using private key of A, and who is supposed to have a private key of A? No one. So this authenticates A. If A if A try denying sending that, then B can say, hey, I'm able to decrypt it using your public key. Tell me who is supposed to, and which means that has been signed using your private key. Tell me who is supposed to have your private key. No one else. So this ensures non-repudiation also. So now this hash digest is visible, which was earlier encrypted. Now it will put its focus on email. Email will be put into hashing algorithm. Again, a digest is created. The digest, which you were able to retrieve by decrypting it using public key of A, and the digest that you have created right now will be compared. If they are same, this ensure integrity. Again, once more, email will be at A side. A will input an email into an hashing algorithm. A digest is created. This digest is used for integrity. Now, private and public key will be created at A and B side. They will exchange each other public key. A will encrypt the message digest using private key of itself. And this encrypted message digest is called digital signature. It will be appended to an email. A will append this digital signature to an email and send it across the other end. A will separate email and a digital signature. B will use B will use public key of B to decrypt the digital signature. If it is able to do that, this ensures authentication and non-repudiation. And now B will input an email into an hashing algorithm. A digest will be created. The digest which it has retrieved by decrypting it using public key, they will be compared. If they are same, data has not been tampered. So this is how the digital signature works. So let me take you through this concept with the help of slides also. So they are used for signing the document cryptographically. To digitally sign the data, that as a sender side, you create the hash of a data. If you have seen, if you remember, A has input an email into an hashing algorithm and a hash digest was created. Then encrypt that, A encrypt that message digest with its private key. And this is called as digital signature. At the other side, when B receives an email and the digital signature, it finds the sender public key. Try to decrypt the signature with the sender's public key, which ensures authentication and non-repudiation. Then it will again create the hash of a data. Check whether the hash you have created matches the hash you have received. If they are same, it has not been tampered. Hashing provides message integrity, and signing of hash provides authentication and non-repudiation. It also involves encrypting the hash value of a message with the private key. So how this works, let's see with the help of a flow diagram. So it is a process which combines asymmetric cryptography and hashing to authenticate message, ensure their integrity, and prevent non-repudiation. So let's look at the process. Charles wants to send an email to Alice and wants that email not to be tampered with in transit. Alice also wants to ensure not only integrity, but also authentication and non-repudiation is maintained. So Charles generate a private key and public key pair, and then exchange his public key with Alice's public key. Similarly, Alice also generates her private key and public key pair and exchanges her public key with Charles' public key. So now Charles have private key, public key of Alice and his private key. Similarly, Alice has her private key along with the public key of Charles. So now this slide shows you the communication process at a sender's end. So Charles input an email into hashing algorithm. A fixed length digest is created as an output. And this digest is encrypted using private key of Charles. Then this Charles append this digital signature to the Alice and send it to the Alice. Alice, upon receiving an email appended with the digital signature, separates the digital signature from the email. Then she will try to decrypt the digital signature with the help of public key of a Charles. If she is able to do that, this ensures authentication and non-repetition. After decrypting the sender's public key, the hashed address from the sender becomes visible. The email is fed into hashing algorithm again to generate a message address. Both hashed addresses are compared. If they are same, it has not been tampered with, ensuring integrity. So this is how digital signatures work. Digital signature can only help you in achieving three cryptographic goals: authentication, non-repetition, and integrity. Integrity is being provided by hashing, and non-repetition and authentication is being provided by your asymmetric cryptography. If you want confidentiality, then you have to take an extra step by encrypting the data using public key of a receiver and then create a hashed address. So digital signatures is being used in communication security, email security, SMMA, many other places. It is used in code security. The it is used in code security. Software developers digitally signs the code, which ensures authentication, non-repetition, and integrity. It is also being used in secure software updates. Quite a time you might have noticed when you try downloading some application, you get a message, error message. The publisher of this website is not verified, which means that they try decrypting the code using public key of a publisher, but they couldn't, they were not able to do it, and then you got a matter. The Form 16 document that you get, which is CA certified, which is signed by digitals, which is signed digitally signed by CA, that is also an application of digital signatures. Digital signatures are highly robust. Digital signatures use encryption to provide strong protection against tampering and forgery. They provide better speed, a streamlined verification process, allowing for quick authentication compared to traditional manual. It offers you less storage, requires storage space requirement to work in its entire cycle, and it is patent free. So exempted from patents, enabling global cost-free use. So this is about your digital signature. So till now, we have covered hashing. Hashing is an algorithm which helps you in achieving integrity, means ensure that data has not been tampered. Digital signature is an algorithm which offers you integrity, authentication, non-repetition with the help of hashing and asymmetric cryptography. Now we will move towards another topic, that is last topic of our session today, PKI. PKI stands for public key infrastructure. Suppose someone approaches me directly and says, "Hey mate, I want to study from you." If I don't know them, then I will say, if I don't know them, I will say that uh, I can't trust you. But at the same time, if I approaches someone with my training, "Hey, I'm a trainer, study from me," then person person might not trust me, because how can he trust me? But if lot my times I take trainings with a lot of companies, so trainers students doesn't know me, I also don't know them, but we were in the class because we trust one centralized authority. Similarly, if I approaches someone with my public key, I approaches someone with my public key and says, "Hey mate, let's do a communication." Person say, "Hey, how can I trust you with your public key?" But I say, "Look, you don't know me, but this is a public key which is being attested by some centralized authority whom both of us trust. So that is we. In that case, yes, he or she can trust my public key. When I share the passport with you, even you don't, when I go out of the world, when I go out of the country, people don't know me. At the immigration, people don't know me personally. But when I share the passport with them, that is signed by passport officer, Indian government, they trust me. So that is same key. PKI is kind of a similar infrastructure. Its communication is same. Asymmetric cryptography is a kind of asymmetric cryptography, means basically you do the asymmetric cryptographic communication. But here you attest the public key so that you can share your public key with those also whom you don't know. So it's a framework that manages digital keys and certificate to ensure secure communication, authentication, data integrity in digital transactions. It consists of many components: registration authority, certificate authority, certificates, keys, and users. So PKI provides you confidentiality, authentication, integrity, and non-repetition. Here, A doesn't means availability. There are many components of it. Certificate authority, digital certificate. Remember, the standard of digital certificate is X.509. Registration authority. Registration authority is an optional entity. You may have it or you may not have it. The policy and procedures, because when you are participating in PKI, certificate authority needs to have policy defined. Even your organization who are using PKI should also have policies defined for it. Certificate revocation, many times the certificate issued by certificate authority has to be revoked. So certificate authority maintains the details of that revocations. Timestamp, the certificate which is being issued are timestamped. They provide non-repudiation support and security enabled application. So whoever wants to participate in PKI, they need to have certificate, which is of X.509 standard, which is nothing but a but an public key and identification information of yours attested by certificate authority. It is like a passport of yours, which has your photo, address, name. Passport is of no use unless and until it is signed by passport officer. So this certificate is of no use unless and until it is signed by your certificate authority. When I say sign, digitally signed. So it is mainly used in online banking and e-commerce. And when it is signed, it is a responsibility of certificate authority for attestation. Like when you go out of India, you are carrying an Indian passport, then Indian government responsibility because they have attested you. So one of the main components of PKI is CA. It is a trusted third party responsible for issuance and maintenance of digital certificate. This is a party which issue the certificates, but it's not like that it randomly issue the certificate. It does a proper verify. You submit your information to them. They verify the information. Once they get satisfied, then only a certificate will be issued. Certificate authority not only issued a certificate, but also handles the revocation of certificate. Quite many times, certificates are revoked because of an XYZ reason. So whenever the certificate is revoked, the certificate authority maintains that revoked certificate into revocation list so that you can check whether the certificate that you are using is not revoked. Then you have registration authority. Registration authority is an optional entity. You may have it or you may not have it. Let's take an example. You are a politician who has won the election. First time you have started meeting, you have organized the first meeting with the people of your constituencies for the work. It's first time lot many unnecessary people your have reached your venue. So next time you said it to you appoint the PA and said, please verify people before they reach me. So registration authority is that PA only. You may have it if there is a big CA, then the big CA may have RA, or sometimes it's CA only which performs the work of an RA. It performs registration duty, it verify and validate the information provided by entities. So whoever wants to participate in PKI, they are issued a certificate by certificate authority. Certificate authority consists of certificate is of X.509 standard. It is nothing but it is nothing but a certificate which consists of your identification information and your public key embedded in it, and it is of no use unless until it is digitally signed. So once the certificate authority creates your certificate, which has identification information and key in it, then it digitally signs it. Like passport officer, print your passport, but it is of no use unless until it has signed it. So let's show me. So certificates includes public key, information about the entity that owns the public key, like suppose it has been issued to me, metadata related to the certificate and digital signature. So let me show you our certificate. As of now, it is a X.509 standard version 3 is going on. So you see a certificate, how it looks like. So if you see here, connection is secure, certificate is valid. So you can see here, this is version. You, they won't mention X.509, but they will mention version. This is a serial number of a certificate which is being issued. This is the algorithm. Issuer, who is the issuer? It is DigiCert. The validity of a certificate. Earlier, certificate was issued for 2 to 3 years, but these days it's mostly for 1 to 2 years. So you see, it was issued on 24 till 25. And subject, the person, the entity to which certificate is issued, it is issued to Zoom. This is public key algorithm RSA, and this is your public key. So this is what I said. Certificate consists of details of entity to which it is issued, and it also includes the public key of it. Then some more information you see, I told you it also maintains information of policies. So you see here, you can get to see the policies. And this is CRL distribution points. Here you can check the certificates which are revoked. So this is how simple certificates look like. So when you want to participate in PKI, you need to enroll yourself. It is a process by which user proves their identity to a CA to obtain a digital certificate. The enrollment process looks like the user proves their identity to obtain a digital certificate. So this typically involves presenting valid identification documents or credential to verify that they are who they claim it to be. For example, company employee might show their employee ID and other verifications document. Then entity who is seeking the certificate also needs to provide public key along with any other required information. Private keys, under no circumstances, you should share it with anyone. You should keep it with yourself. And then CA goes ahead and apply and create a certificate which is of X.509. It is like a passport officer has printed your passport, but it is of no use unless and until passport officer put a stamp on it. So certificate created is of no use unless and until certificate authority digitally signs it. When I say digitally sign, it means that sign it using a private key of a certificate authority. And now it will give it to you. So once it has created, it has been given to you. So now you got a certificate. Ajit got a certificate, and Ajit shared it with Amit. Amit got got a certificate from Ajit, but how can Ajit directly starts communicating? No, Amit will verify the certificate. How will he verify? First and foremost thing is he has to trust the certificate authority. Because if you don't trust the certificate authority, then how will you trust the certificate issued by certificate authority? So CA has to be trusted by user. So Amit has to trust the certificate authority. Amit has to trust the data. And then Amit will check whether the digital signature is authentic or not. How will you verify the digital signature is authentic? Amit will try to decrypt it using the public key of a CA. If he is able to decrypt it using public key of CA, which means that it has been signed using private key of CA, and who is supposed to have a private key of CA? Only CA. And Amit will also check the certificate is not listed on CRL. CRL is revocation list. So these are the verification process. Sometimes certificate, then Amit will retrieve the public key after doing all these things. Amit will retrieve the public key and he will do the communication. Sometimes certificates is revoked because of an XYZ reason. I give you one example. One of my engineers, long way back, I used to work in SOC. One of my engineers, what he did, vendors asked for quite quite a time, miss quite many times, we used to get we open an incident with vendors, OEMs, and they ask one standard ask from them is submit the configuration. So he has submitted the configuration without sanitizing it. So that was a Cisco ASA SSL box, which has private key and public key installed on it. So private key was revoked, was revealed. So we immediately asked for the revocation of certificate. So this is one of the reasons. Sometimes certificate is erroneously issued, the security association changed, or details got changed. So there are many reasons why certificates are revoked. So whenever certificate is revoked, certificate authority maintain that in a revocation list. So there are two ways to check the certificate. One is you manually download the revocation list. Earlier, this was a traditional legacy method. Like for example, you download it every Monday, Thursday. But problem with this method is, suppose you download it on Monday. Your certificate, some certificate got revoked on Tuesday. So you will be using a revoked certificate till Thursday when you download it again. So these days we have OCSP, Online Certificate Status Protocol, which checks the revocation test in the real time. So these days we are using OCSP protocol to check the revocation list in a real time. So this is about your PKI process. So in the next slide, it is just about the PKI process in a nutshell. Suppose there are two people, A and B, which should participate in a PKI process. User A is a sender. User A generates public key and private key at their systems. Then user A wants a certificate. So user A sends public key and identification information to a CA. RA, if you have RA, if CA have RA will verify the information. If not, then CA will verify the information. Then CA will go ahead and creates a digital certificate. It is like printing a passport, but it is of no use unless and until it is digitally signed. So CA will digitally sign the certificate and send it to user A. User A receives the certificate and he send it to user B. User B is a receiver. User B, before retrieving the public key and start the communication, he will verify the certificate is valid, certificate is issued by certificate authority, and it is not revoked. Then it will retrieve the public key and they will do the communication. So this is about your PKI process. So we have covered hashing, digital signatures, and PKI. So that is about from my side. If someone have any questions, you can ask. I have my batch on CSSP. If you want to go and learn these topics in detail, I have a batch starting from 1st of June about CSSP, where we will be covering all 8 domains of CSSP in detail. So if someone wants, if someone is interested, it is a weekend batch from 8 a.m. to 12 p.m. ISTs, where I will be conducting a session. I'm an authorized IC2 trainer. I've been tracking IC2 batches, CSSP batches since 2017. I've taken 150 plus batches. And this is the number which is mentioned here and email ID. And even you can, my name is Ajit Pal Singh Vathavan. You can contact me on LinkedIn also for any query, not related to batch only, for any query related to career and anything. So thank you very much, mates. If you have any questions, then feel free to ask. I don't see a lot of people here. So thanks. Thank you very much. Bye.